Morning, everyone. Apologize for that. I failed to get my Zoom off of mute there. Um, as I mentioned last week, we're going to start this week's lecture off by talking about water pollution. This is a major topic. Water pollution actually impacts somewhere between 2 and 3 billion people a year. In general, that's a little bit of a misnomer in the sense that we tend to think about water pollution, but as you learned today, there's a very big, subtle but important difference between pollution and contamination. But just give you some perspective as we get started here. Um, Low quality water resulting from either pollution or contamination influences about 2 to 3 billion people each year on planet Earth and can have pretty dire, extreme consequences in certain areas, particularly areas where there's limited opportunities for their accessing other water resources, or where people don't realize they're drinking water of really poor quality. So one of the themes of today's beginning of today's lecture and this lecture for this week, of course, is going to be talking about what we tend to think about in terms of low water quality, which is the sort of the industrial drainage pipe bringing bringing wastewater, something like that, out to the environment. In many cases, those can be, as I mentioned, can be horrible in terms of environmental damage, ecosystem damage, and damage to human health. But by and large, actually, a much bigger or greater number of people are actually influenced by naturally occurring contamination related to the chemistry of the geology of the area people live in, which will be a major theme of our lecture as we move on this week. So, getting started here, I think one of the places I like to really begin the discussion is thinking about what the difference is between water contamination and water pollution. Um, it's a little hard doing this in online, but I'm showing you two pictures here. Can anyone tell me, can anyone tell me which of these two pictures results from water, from human-induced reduction in water quality versus naturally occurring water quality? Anyone brave enough to wager a guess? You have a 50-50 chance of being right. Well, the image on the left, the image on the right, I think we could both all could agree that there's a problem with water quality. None of us would want to drink this water. There's clearly evidence of oil and hydrocarbons, in both of these. The one on the left is actually a naturally occurring seep. It's called an oil seep. There's actually, just up off the shot here, there's a place where oil naturally discharges out of the ground. If you drink that water, or animals drink that water, they are subjected to really poor water quality and can have major implications for their health. But there's nothing that any humans did that actually caused this. The one on the right is actually the result of a spill. This is actually a picture from a spill where there was actually oil spilled by an overturned truck that drained down to a hill, and the water accumulated in this area, and you can see there's major sludge buildup there. So clearly that one, there's a human cause to that, and humans are responsible for that, both financially and environmentally. But in both cases, the water quality result is the same. So other examples here. This would be a third example of the oil spill from the Condo Bay in the Gulf of Mexico about a decade ago now, I suppose, and also obviously that's caused by humans. So two vocabulary words I promise you will be on your worksheet for this week, and I'll definitely show up on the next exam. But it's an important difference. Contamination is an implication that there's unsuitable water quality. So both of these water types are actually contaminated. Their water quality is not suitable for drinking, and we'll talk about this more as we go along in this lecture. But unsuitable is a very subjective word, and it's meant to have a pretty subjective meaning in environmental parlance. So what that means is that contamination can be subjective to the type of intended use for the water. If you're going to use this for drinking, we obviously agree this is contaminated. If you're going to use this for agriculture, we'd obviously agree this is contaminated. And quite frankly, I can't think of a use of water like this. But there's also a gray area in a lot of environmental water quality stuff where contamination of water, for example, high nitrates might be, from agricultural activities, might still be acceptable for agricultural practices, may even be useful for power generation practices, but really probably would not be suitable for drinking water quality depending on the level. So the key here is contamination only tells you about whether The water quality has been compromised. It doesn't tell you whether it's natural or anthropogenic. Key differentiator here is the word pollution, and pollution is used to imply human-induced decreases in water quality, and that type of water quality decrease by pollution can take on a lot of different forms and a lot of different perspectives. This could be result of someone dumping waste, dumping contaminated water into the environment, letting it percolate in the groundwater or lakes. It could be done from unintended by putting fertilizers on fields. It could even be it can be, in some cases it can actually even be legal. Nonetheless, it can be a cause of pollution. One of the great debates in the last decade have been about the relationship between hydraulic fracturing and shale gas development with methane and releases and other types of contaminant releases in the environment, whether they're naturally occurring methane pockets or whether they were actually induced by humans in terms of pollution. So, before we get going again, contamination, unsuitable water quality could be natural or caused by humans, or anthropogenic is the word we use for that. Pollution is human-induced decreases in water quality, not necessarily somebody at fault. So as I allude to this, this can take on a lot of different forms. This is just an example from shale gas development where we know there were wells drilled into the Utica and the Marcellus in the region, people trying to drill a well, fracture the shale to get gas out. But there are all types of different aspects of methane that occurs naturally in aquifers, from septic tanks, swamps, methane that's migrated to the surface, methane that's released by drilling, sometimes methane they hit on the way down, can move along faulty wells and well annuluses, as opposed to methane that actually is released by fracking that we heard so much about in the media. So, taking a step back, what do we mean by this pollution? The key thing here is water pollution is going to be the degradation of water quality. I've already told you that by human activities, but it's measured by a variety of different criteria. So this can take on the form of biological criteria, such as putting cholera or something like that into water, or allowing it to exist by putting nutrients in the water. Chemical pollution, which can be nutrients like nitrates and phosphates. It can be metals like arsenic or cadmium. It can even be methane gas, for example. Or physical criteria, for example, putting sludge or a solid material into the water that can reduce water quality. All can fill the form of pollution. And again, the important thing to think about here is the degree of degradation, or the impact of that degradation, depends highly on the intended use of the water. Obviously, there's a big difference between what we're going to try to drink versus what can be used for agriculture or power generation. And as I alluded to in the last lecture on Friday, the intended uses of those waters, they don't just take a stance on important stance on what we think about these in terms of water quality. It also, human consumption of water is typically the best quality water by far. Pretty much there's little amount of wiggle room in terms of what flexibility is there in terms of that water quality. But agriculture and power generation could also be, water that's compromised but doesn't influence those processes. One of the big trends, for example, in Southern California is there is now activity for shale gas development and oil development by fracking in that area. Agricultural uses, that water has to be disposed of in some way, treated or released into streams. And much of the agricultural area, because the water is relatively low in metals and low in salinity, as long as there's no fracking fluids, folks are actually now using that for agriculture. And the limited amount of salinity actually allows the water to be used perfectly adequately, and similarly for power generation. So, both of these processes can degrade the water quality itself, make it unfit for human consumption, but oftentimes many aspects of water can be used for those purposes later on. Specifically, we're going to give another term here. Pollutant is a substance that in excess is known to be harmful to desirable organisms. So, the things we concern ourselves with, we're going to think about the threshold at which there's contamination, right? Where there's the reduction in water quality to the point that the water isn't viable. So, as I mentioned earlier, pollutant like salt, chloride, can in excess, the salinity of seawater, nothing can grow. No freshwater plants can grow, no vegetables or agricultural things can grow, and therefore it's harmful to organisms. So in things like salinity, the level matters. For stuff like lead, cadmium, arsenic, there's really no known biological role for those, except for as a toxicant, and as a result, the polluting substance in excess can be extremely low for those types of components. So, just to reiterate, lack of access to clean water from one of these three things, biological, chemical, or physical criteria, affects 40% of the world's population and can have major implications for health. As we'll talk about later in the lectures, probably on Friday, naturally occurring arsenic that's eroded from mountain belts like the Himalayas into alluvial aquifers that we discussed in the last class. Arsenic contamination like that alone accounts for about 25% of the total pollution. 25% of the contamination, all naturally occurring, that impacts human health in a pretty extreme ways in many areas of the world, particularly around the Himalayas. So, just to give you a sense of, chemical related pollution, that's often what many people tend to think of. If you want to look at it from that perspective, by and large, the largest source of chemical pollution is actually related to nutrients in rivers of the world. Inorganic nitrogen, phosphorus account for a great amount of this. The other ones that were very important, particularly in earlier ages of steel making and things like that, are mercury, lead, zinc, copper, cadmium, nickel, and chromium. That list, if you think about natural system, extends to arsenic, but these are major concerns. And what you don't even see here on the scale is actually organic contaminants like organophosphates and basically halogenated organic components like benzene, toluene, and xylene, which are really prevalent near gas stations and other types of refining. So the punchline here is if you look at human activities, look at industrial activities, we often are taking natural substances and synthesizing new substances, or synthesizing substances that aren't commonly present in the natural environment. And as a result, you can see that in those cases, you often find that there are environmental implications related to these things. So what we're going to do basically from now until the end of the water quality sequence here is go through and talk about selected pollutants. I'm going to give you some background on each one of them and just kind of get you a sense of what to look at. There's entire courses. I teach one every other spring about environmental contamination and the techniques to measure it and interpret it. But I'll just give you a sense of the sort of the menu of water pollutants that we have to be concerned with, and many more that are emerging that we won't even cover in any great detail. But the way I've chosen to cover these is actually in terms of their prevalence in the environment across the world. We tend to think about things like microplastics and methane release from shale gas development as big topics because we hear a lot about them now, but and they're incredibly important. But there are some things that actually are much more massively important on a volumetric basis around the world that we haven't, you may not know as much about, in fact. So one of the most important water pollutants that impacts water all over the world, you probably driving around somewhere this summer saw a pond that was influenced by this, is basically oxygen demanding waste, or ODW. This is typically caused when organic material, it can be dead plants, animals, leaves, it can be sewage, for example, it can be a lot of different sources, is broken down by bacteria. And you'll often see this occurring in small little ponds and lakes where you sort of see it go mossy and then green and then kind of looks stagnant for the rest of the summer. Nowadays, many people have little pumps that create fountains in the middle of the stream to keep it aerated. But the net influence of that organic matter is, naturally occurring bacteria and plants in the water typically start undergoing photosynthesis, using sunlight to grow. They actually consume oxygen, or they produce oxygen by photosynthesis, but the bacteria that live in tandem with them eventually break them down as they start to die. And that actually, the bacteria require a large amount of oxygen. That's called aerobic bacteria. And as a result, they consume the oxygen that's available in the ocean or the ponds or lakes by exchange of the atmospheric oxygen levels with the water. Once you get that sort of rind of moss and the bacteria that are sort of chewing up the dead algae and whatnot consume water, the oxygen levels can drop off pretty quickly, and as a result, they themselves many of the plants are no longer able to die. That decomposition sort of self-perpetuates. It's a positive feedback loop with very negative implications, and result more oxygen can be consumed. And what this does eventually is it leads to something called eutrophic conditions. There's no water left in the, no oxygen left in the water, and as a result, the fish and other organisms, in the lakes pretty quickly die off. And you see these as fish kills in the open ocean as well as lakes and ponds. Usually, running water tends to fare better, streams and rivers, but stagnant bodies of water, particularly in times where late in the season when droughts occur and water levels go down, you can often see that they sort of become stagnant, and this process sort of runs out of control. So, there's an important term here: the amount of oxygen used for bacterial decomposition. It's called the biochemical oxygen demand, and this is a measure where people are often measuring. This is a metric, I should say, where people are often measuring in lakes and ponds, even in groundwater, the oxygen levels and the biochemical oxygen demand, basically how much oxygen is there needed in that water body to support aerobic bacteria. And once those levels start to drop, you can see a prevalence of these types of oxygen demanding waste having an influence. So BOD, this biochemical oxygen demand, is a pretty important and common measure of water quality. The higher the value, if you buy a home, for example, or you're looking at a property, something like that in the future, and you get your water report back and has a high BOD number, that's pretty bad. It indicates there's a high level of decaying matter in the water, and basically you're going to be susceptible to these eutrophication processes. I don't really do a lot of consulting work for people who have individual ponds, but you often get people asking you to measure the water quality for a pond, for example, and pretty typically, they're trying to grow fish, they're trying to grow something in the ponds, and pretty typically, this is what actually ends up killing most of the fish. So, the next wave of contaminants actually kind of brings up two additional points here, which is pollution point source and non-point source pollution. So here's a pipe that comes out into the ocean. In this case, it discharges basically sewage. This is off the coast of Boston. It discharges sewage out into the ocean, and you can see there's plenty of fish here trying to eat we'll call them nutrients. Some people might just call them turds, but basically that's a point source pollution. The oxygen demanding waste tend to be where they are. They're in a lake or in a pond. But a lot of the other sources of pollution we're going to talk about are things that actually can be moved around or can be transformed by these biological processes in the natural environment. As a result, we differentiate them by point source and non-point source pollution. So point sources, an example would be somebody having a pipe, discharging sewage effluent or discharging waste into a river, or a stream, or the ocean. And other examples of this, if you saw recently the movies about the C8 or the Teflon components from DuPont and whatnot in West Virginia, those were actually pipes leaking this into the environment, and those are called point sources of pollution. The alternative non-point source pollution are things that are sort of released in a lot of different places, often at low levels, but they accumulate in areas and become major sources of contamination. A good example of non-point source pollution is the nitrate and phosphate contamination from agricultural activities, from fertilizers. So, on any farm, most people are conscientious farmers. They try to keep nitrate and phosphate levels low in the waters. They try to avoid contamination. And on the aggregate, they may do very well on a granular level, but on the aggregate, some of that runoff gets into streams, gets into lakes, and then you see major rivers like the Maumee going into Lake Erie, the western basin of Lake Erie specifically. You can see it accumulate to the point where non-point sources, where it's not just one person or somebody we can go and easily stop. Non-point sources of pollution can become much bigger issues, for society. Kind of has the issue of the tragedy of the commons. It's not easy to point to somebody. There's no one to sue. As a result, it's hard to track down. So, in this case, this isn't, Boston wasn't just trying to get away with something here. There are allowable releases for many contaminants, and there are strategies specifically for gray water and sewage water to put these into rivers or put these released into certain oceans or something like that. So this is allowable, but The reason I bring this up is, in addition to those lakes, you can often see in areas like the areas around sewage discharge areas in coastal cities, where the oxygen demanding waste releasing this, you know, uh, uh, sewage treatment plant effluent can often reduce local reductions of oxygen, and the oxygen demanding waste can be, be pretty prevalent. So, examples of things of this that causes oxygen demanding waste, oxygen shortages or oxygen demanding waste. Leaves, agricultural runoff can cause algal blooms, can lead to this, and sewage discharges. If you look almost exclusively wherever there's a sewage discharge area, in that area or shortly around that area downstream, if it's a release into a river, you'll often see the oxygen demanding waste will increase, the BOD levels will increase until that mixes back with more water as it percolates, along or mixes with the global ocean water. So the next major component of pollution is actually biological. So this is the last one was caused by biological processes, obviously, but pathogenic organisms or pathogens is a major issue, particularly in the developing world, that influences human health and animal health in a profound fashion. You've probably heard of a variety of these diseases. Cholera, typhoid infections, hepatitis, and dysentery are all waterborne diseases. They're all caused by some form of pathogenic microorganism that's usually released with fecal matter, typically, and can accumulate in surface waters and/or groundwater. In fact, we talked about Darcy's law and the fundamentals of the porosity, permeability, and hydrologic gradient controlling groundwater flow in the last lecture. It was actually issues with cholera outbreaks, I believe, in Vienna, that caused Darcy to develop sewage treatment, or not sewage treatment, sewage pipes infrastructure to actually pull the waste away from the city because cholera outbreaks are so prevalent. And again, these are all forms of biological contaminants, all caused by pathogenic microorganisms. And there's a sort of a generic way of monitoring biological pollution is by measuring fecal coliform bacteria. In most communities, even rural communities all around the U.S., you can, at least last time I checked, you can take a sample of your water into a hospital, local health clinics, or local environmental office, depending on where you're living, and they'll either for free or very cheaply measure your water and tell you your fecal coliform. It doesn't tell you much about the water quality in total, but it's a really quick to measure, reliable metric for the biological pollution, the likelihood that some of these pathogens are going to be there. The idea is that fecal coliform bacteria is excreted with human and animal waste. It's almost a tracer that will let you know if these things are likely to be in your water. So these are actually, themselves harmless. They're found in your gut and your waste, and they're, totally natural. But they allow you to sort of monitor whether this source of water is actually being exposed to other, to sort of fecal pathogens that may be prone to these other types of infections related to that. In some cases, though, there are other forms of E. coli and fecal matter that can cause outbreaks of major illnesses and death. For a perfect example, this was E. coli, or is E. coli. This is responsible for about 60 deaths in the U.S. and about 70,000 illnesses in the U.S. alone. E. coli and other forms of organisms similar to this, contribute to dozens of thousands of deaths globally, and obviously many millions sick a year. Particularly dysentery, we tend to think about the worst ones, but dysentery is an example, something that influences millions of people every year, not including the U.S., but also in developing nations where the water quality can be diminished by pathogenic organisms. A main area where this becomes a concern is people drinking surface water. The Ganges and the Brahmaputra are an area that get a lot of attention and publicity around this issue because people are discharging waste all along the rivers. They're the main sources of water along those alluvial aquifers we talked about, and as a result, it's sort of endemic to have a variety of these pathogens, particularly E. coli, in the water, and as a result, many people have to filter their water for drinking. However, obviously, in areas where there's extreme poverty, people can't necessarily afford to do that, and as a result, people either become sort of pseudo-immune and develop resistance to these, or they don't. So it can influence a lot of people's health each year. So worldwide, deaths and illness associated with these waterborne pathogens um, are huge. We mentioned this, um, dozens of thousands of deaths and millions of illnesses a year on every recurring yearly basis. And as I mentioned a few times, regard to natural disasters such as hurricanes, for example, these pathogenic organisms are some of the main contributors of the death tolls and hospitalization tolls after in this case is an earthquake, but after major natural disasters. So, just for example, the Haiti earthquake we talked about. We talked about the water, um, you know, water contamination being a major issue for these types of after floods, after hurricanes, after earthquakes. Um, but just in Haiti in the 2010 that we talked about a few months ago now, the cholera outbreaks themselves claimed 3,000 lives and hospitalized 50,000. Nothing to do with the earthquake itself, all with people being moved around, having to rely on different water resources, no longer having infrastructure to take precautions of filtration, things like that. And as a result, many perished just because of the presence of cholera in the area. Moving on to what many would believe, or many would talk about as being the biggest source of pollution that affects a variety of people, is actually one of the best examples of the non-point source pollution I already introduced. This is might look like a story or an image rather out of a horror story, but in fact this is an image out of Lake Erie Basin during harmful algal bloom outbreaks. So this is again a perfect example of non-point source pollution, where it's not a particular farm or a particular sewage treatment plant. It's actually a little bit from everybody that adds up, and the aggregate is a major implication. So um, the key thing is the nutrients are typically relying on nitrogen, which actually is nitrate, and phosphorus, which is PO4, which gets into water. Sorry, PO5, which gets into water. And those nutrients are deliberately applied as sort of fertilizers to help grow crops. When you see them lead to algal blooms at this level, it's much the same idea as the oxygen demanding waste. It actually leads to eutrophication of the water in much the same way, based on the fact that those same nutrients that stimulate plant growth in farm fields actually stimulate algal and as well as bacterial growth in the open ocean water, and as a result, the bacteria that's consuming them, sort of run amok and decrease the water levels. So most of the eutrophication from harmful algal blooms is actually tied to agricultural runoff. There are generalizations here. The more forested land in an area, the more plants and trees and whatnot in riparian zones and water systems, the more likelihood they can actually lower the concentrations of phosphorus and nitrogen, phosphates and nitrates in the region. They basically plants, trees, etc. will selectively uptake these nutrients and remove them from water. So riparian trees or forested rivers and streams themselves, the roots of those trees will select this out of the water even as it flows by, help support their growth. But alternatively, obviously, agricultural areas where we're depositing, nitrates and phosphates deliberately, they tend to be higher levels. So it becomes a major concern about land use change. If we have a scenario where we still have forested areas, or they can even be wetlands, for example, that are actually intermediaries between the sources of the non-point source nutrient pollution and major lobes of Lake Erie or other bodies of water, they can often uptake enough of this to mediate the process. But as we increasingly convert to more and more agriculture, less forestry, and/or as we see the amount of fertilizer being deposited increase, the balance can get out of whack pretty quickly. And these result in blooms of algae, the harmful algal blooms. HABR is what a lot of people sort of reference them at. You look in, read a newspaper article pretty quickly. HABR is commonly brought up. But even though this is in Ohio, maybe some of you were directly affected by this, living up in the Toledo area. Maybe some of you are just hearing for the first time. But the effects of these algal blooms can actually be more than just looking at green water and realizing eutrophication. So the biggest aspect is that these algal blooms become thick mats of algae on the water surface. They themselves lead to very low oxygen levels. Any oxygen that's exchanged with the atmosphere is pretty rapidly consumed by bacteria as they're decomposing the organic matter. But the other implications are that they actually block surface light from penetrating deeper in the water column, and as a result, a lot of the plants and vegetation, which is also naturally filters out some of these nitrogen and phosphorus for their own nutrition, um, basically die of a lack of sunlight. Uh, the algae, consume oxygen as they decompose. This is a link back to that biological oxygen demand. It lowers the content of the water, and as a result, you see pretty rampant fish and aquatic deaths. Fish kills in the area, mollusks, all the things that we depend on for the economy, for food sources, and for just a healthy ecosystem can be affected pretty dramatically in these events. Um, and most importantly, when these algae, the algae have a variety of toxins in their sort of makeup, and their chlorophyll and whatnot, and as their normal biological chemicals that are produced. And when they die, they're released, sort of contemporaneous with or following these algal blooms. They start to die, and they themselves can actually cause a variety of toxic impacts. And this is actually not an example from Lake Erie, but it's a common in algal blooms near Gulf of Mexico, or sort of um, areas of the Florida Keys, for example, where harmful algal blooms can occur intermittently, and as a result, sometimes you can see these toxins build up. As the algal blooms die. Here, we're talking about the toxins released by the algae themselves. One example is ciguatera. There's actually a neurotoxin. It accumulates in fish that are feeding on algae during this time, and as a result, very specific times of the year, with relatively modest algal blooms, even you can find that ciguatera and neurotoxin can affect a lot of people. There's an example when I was doing a postdoc at living in Boston, where off the Cape Cod there was a red tide algal bloom offshore, and quite a few people actually ended up getting neurological damage, partial paralysis of their legs and limbs, and neurological deficits just from eating fish in small communities. And so ciguatera is just an example of one of these that have got a lot of issues. People, innocently eating fish in that area. Some people experience, vomiting and diarrhea relatively quickly. Some people sort of notice a headache, or, dental pain, maybe lack of coordination, full body itching. Some people will even see heart attacks or permanent neurological damage. But as a result, there's a lot of caution in terms of making sure you don't drink the water in terms of these cytotoxins and neurotoxins, but also to make sure that you aren't even eating fish that are eating things from that water during that time, because they can cause a whole variety of long-term health effects. So, as I mentioned, these eutrophic events from harmful algal blooms is not just a Lake Erie problem. A perfect example of this is Gulf of Mexico. Almost annually now experiences these eutrophic zones, or low oxygen zones. Same process. There's fertilizers deposited all throughout the southern parts of the United States, southeastern part of the United States. A combination of Mississippi River and some other rivers in the area will aggregate the nitrogen and phosphorus pollution, and when that gets out into the Gulf of Mexico, particularly in the summertime when it's hot, there's high evaporation, and there's not as much ocean circulation, not as many storms bringing water, mixing it in and out of the Gulf. You can see eutrophic events where there's harmful algal blooms, red tides, and in many cases incredibly large fish kills. Where you can Google these, but I don't think I have a picture of it later, where there's all you can see is just dead fish floating on the surface. So these are often called dead zones. They develop in the summer after that nutrient load's been washed out. The algae will sort of start to grow if they're broken up by storms or tides and whatnot. If they're mixed enough, they can be prevented. But in reality, as either you get a year that gets warm water and really intensifies that growth without a lot of storms and mixing, it can tend to develop. But obviously, in times when, as we're seeing in the last generations, where we're putting more and more fertilizer into the Gulf, just like Lake Erie, it actually overwhelms natural processes, and red tides can be pretty problem. So The nitrogen in particular input in the Mississippi River is believed the cause of eutrophication eutrophication. And it's actually, as you can see here, it can be a pretty large expanse of the coastline that experiences this sort of dead zones as a result of nutrient pollution. So, this is an example from Great Lake St. Mary's, Ohio. It's the largest inland lake in Ohio. It's about 21 square miles, and you can see here the algal mats and foamy algal mats that sort of wash up the shore are just a putrid color of green. You can feel the sort of the thickness when you touch the water, and all these are reached pretty much extreme eutrophic conditions, and a huge problem with nutrient waste runoff. Obviously, although it might be our largest inland lake, an area like Lake St. Mary's is relatively small. The smaller the catchment, the more easily we can be overwhelmed by a constant source of fertilizer and other waste runoff. But the reality is that even as I showed in the last picture of the Gulf of Mexico, this can influence water quality on pretty expansive areas, actually. So, I mainly have talked about fertilizer and other agricultural components that have phosphorus and nitrogen in them. Also, human waste, animal waste, even animal manure has some amount of nitrogen and phosphorus in there that can be problematic. These can cause a variety of blooms, and as well as Ciguatera, the microcystin is the one that's most commonly a problem in places like Lake St. Mary's and Lake Erie Basin, for example. The key things here is, along with the reduction of oxygen in the water for eutrophic conditions, the microcystin is a toxin that can greatly influence health. So, what are the implications of this? I'm mentioning we're gonna kill off. We're gonna see big fish kills. I mentioned that the possibility of neurological and microcystin toxins that can cause human illness, paralysis, even death. One of the sort of unintended things, people still walk along these areas with their dogs, and dogs lick a little bit of the water, and they can be killed. But the other aspect here is just the loss of economic activity. There's still, I believe, in excess of, I forget the number exactly, but I know it's more than $1 billion fishing industry on Lake Erie. Right, that's the economic impact for Ohio alone, for fishing, for food, along Lake Erie and in these areas. So these can have, they may not be anywhere near as big as agriculture, but they can have major implications for the economy as well as just the environment. So, looking a little bit more at the case of Lake St. Mary's, there's always the question of what we can do in terms of solutions. Obviously, we could grow enough plants to feed the world without having to put down fertilizers. That'd be swell. But the reality is, we all agree we need food, and there's been a great amount of science and innovation just to make sure we can actually increase the nutrient load to the point where we can develop the food we need. So many have turned to looking at solutions like adding other chemicals, aluminum sulfate, for example, or copper sulfate's another one to the lake water. If you've been around a pond where you see it looks very sort of unnaturally blue in the summertime and has no algae, it's usually because one of those two components has been added, copper or aluminum sulfate. The key thing is that it absorbs the phosphorus as a key nutrient that stimulates the algal blooms. Some suggest it actually is mildly toxic to those components, that also keeps them away, but clearly it might actually help clean up the water in a given area. The problem is, again, it's not really a very sustainable approach, since you're just adding more chemicals that are going to have other issues tied to them later on. But that's one of the things that people have worked on. The more common big picture approach that people have worked on the last few generations, at least the last generation more so probably, is the establishment of wetlands around the lakes. And the idea being that if you create wetlands along streams, along rivers, along the discharge areas that carry the nutrients to the body of water, that you can basically remediate that water biologically, sequester that nitrogen and phosphorus in plant growth that's not algae, in the wetland or in the riparian zone, and that'll minimize the influence. This is probably the area that has the greatest success to date. You see major efforts to do this, and in many cases, I think the lesson learned here from a sustainability perspective is this is kind of a return back to the natural state. Oftentimes, I think Lake St. Mary's is actually a human-made uh, lake. Point of fact, was built, and if I remember correctly. But in many cases, the areas near the Great Lakes, for example, have very large zones of riparian zones, wetlands, and even like tall reeds and stuff like that that sort of naturally buffer the lakes. We've often our history as humans in this area is we've moved that back and back and back to create more land for living agriculture and things. And as a result, we've sort of changed the land use practices in that from the natural state to something now. So in essence, we're sort of just taking it back to the way it was to remediate this process. And then there's also a whole variety of agricultural practices in the surrounding area uh, that are sort of being challenged and changed to try to minimize this. The timing when phosphates and other nitrate fertilizers are going to be deployed, the amounts that are going to be used, and just trying to avoid things like when the ground's frozen, there can be a large amount of runoff and things like that. Building banks in the fields to control deposition. But the reality is that it's a very tough problem because a lot of, it's in a slightly pessimistic sense, the die has been partially cast at this point, if you will. A lot of the water is actually, a lot of the nitrate and phosphate pollution is actually dissolved in the groundwater and it's in the surface water. And as a result, most of these efforts are very good at, in terms of, soil control are really important, but they mainly control solid particles or absorbed phases of nitrogen and phosphorus, where it's both a solid and a dissolved in water phase that can be a problem, suggesting need for a variety of these things, such as better controlled sediments as well as better establishment of wetlands. So looking at this in a bit more detail from Lake Erie, this is the area that experienced some of the worst. The western lobe of Lake Erie experienced some of the worst algae contamination. You can see quite clearly the water there. I won't even comment on it. It's not a nutritious new kale fruit drink or kale diet drink. It's actually an example of what the water with that algal mat looks like. Needless to say, none of us would want to drink that. I believe this was from the 2011 bloom, which actually covered about 1,930 square miles. 20% of the lake and almost all the western lobe of the lake was pretty much saturated with this. And this is the picture is from the algae. This picture was in 2014 from the algae at the Toledo water intake. Which, if you remember back to 2014, there was actually a period there where we had to shut down the water intakes and try to come up with a way to treat this. So, this is a record of summertime blooms, all related to nutrient releases, and you can see that people have pointed out that this oscillates depending on the year, depending on the precipitation patterns and the temperature conditions when planting's occurring, how much fertilizer is being used. But most people seem to suggest this has been relatively flat, but it seems to have a bit of an increase in recent years, and there's a lot of debate about some aspects of that, which we won't be able to get into entirely in this course. But the clear thing is that both in 2011 and 2014, you saw these major blooms, which have remained a problem, and actually today remain one of the most important environmental problems in the state of Ohio. So, what are some of the factors that most folks agree on in terms of causing the algal blooms in Lake Erie? One of the things that's always brought to attention is that the seasonal climate can play a strong role. For example, if you try to plant at the same time every year, and farmers are very sophisticated about this, they have great strategies for minimizing this, and I think they're very committed to doing this the right way. But for example, if you try to look at seasonal climate, if you had a really late, a long winter, a late spring, the ground was frozen, and you tried to put your fertilizers on there, there's a pretty good chance when there's frozen ground there'll be runoff, for example. So the seasonal climate aspect is a major issue. Looking at wet and dry springs, one of the things people bring up is that if you have a really wet spring, you might get a lot more runoff that would bring that into play. And we'll talk about that more in a second here. But just to give you a perspective from this western lobe of Lake Erie, 63% of Lake Erie's watershed, and a larger percentage in the western lobe, although I don't remember the number, is actually used for agriculture. So if you want to think about it from that perspective, the likelihood that this is going to be an ongoing problem is pretty high. So let's look at the 2011 or 2014 major blooms in a little bit more detail. What really happened? Um, one of the key factors in the western part of the basin, which is one of the areas most susceptible, is just the natural geological setting. It's actually the shallowest part of the lake. The average depth is only 8 meters. That's 25 feet. As a result, if you think about that whole parcel of water column having exchange of oxygen and accumulated oxygen from photosynthesis over time, you would expect that the higher the water column is, the longer it would take for that water to become completely degraded and completely removed from oxygen. As a result, when you're in the shallow part of the basin, only 8 meters deep, it's easier to see how much oxygen, same amount of oxygen consumption, how that can be removed much more quickly in that area. Some of the bigger issues that affected that region is that these are actually some of the most extensive ice covers, which the 2013-14 year leading to the 2014 bloom was actually the second most extensive ice cover in the area of the western limb of Lake Erie, but also in the frozen soil in the area. So one of the factors is this actually retained heat below the ice cap of the lake and enabled a pretty quick recovery. So the water got abnormally warm when spring arrived because it was so well, effectively insulated by ice. And then, other factors are that the particularly for Toledo, excuse me, is that at the time of when this sort of broke out, the wind currents were blowing from north and northwest to southeast, and actually concentrated the algae near the water intake. But another aspect of this is just simply put, you had a cold, late, icy winter. As a result, there was a lot more runoff as opposed to groundwater infiltration. As a result, the Maumee River got both more water, but a lot more concentrations of phosphorus and nitrogen. Not necessarily an outlier year in terms of precipitation, but just in terms of the time it took for the watershed to sort of warm up and allow water to percolate into the ground. So it wasn't that precipitation was high, but there are many other factors that played a role. And the biggest one is basically the idea that we had a long, cold winter with the ice pack and lack of infiltration, so it all got concentrated at a certain period of time. So just to wrap up on this, the microcystin levels reached about a ppb in drinking water by August of that year. This is higher than the level recommended by the World Health Organization, meaning the water couldn't be used in a city like Toledo. Boiling doesn't affect the toxin, so it's something that has to be filtered out, or another source of water needs to be obtained. So as a result, they had at a major cost to the city of Toledo, they had to develop filtration apparatus to get suitable water. But relatively speaking, within a few days, it's actually declared safe to drink again, although it was a major problem in terms of filtration and engineering the area. So just to close the loop on this, I think that most of the people in Ohio now agree this is an important issue, and we need to do something better about it. By about a year after that, 6 months after the water shut down, or 8 months, I guess, the Ohio House unanimously passed a bill to help reduce the farmland manure runoff. Basically, the main things of that is that the farmers are prohibited from spreading manure or other fertilizer if the ground's still frozen, or if it's saturated. If it's totally wet, it wasn't the issue in 2014, but it's another way that runoff could increase. And the other aspect is that it's prohibited from spreading. The forecast calls for a 50% chance of precipitation of more than 1 inch in a 12-hour period. That gets a lot of subjectivity, but the key aspect here is that there's guidelines that are sort of communicated to the public. But basically, if there's a high likelihood of a great amount of rain, basically the idea is to avoid deploying fertilizers during that time. But pretty clearly, I'm just going to show you some more pictures here. Pretty clearly, this is an issue that's going to be on throughout, probably, unfortunately, most of our lifetimes. This is the West Sister Island in Lake Erie, and you see the scope of just the immense amount of eutrophication and nitrate, and phosphate contamination in the area. This is the picture of the Maumee River going into Toledo. You can see that even in the river, there were major major buildups of the harmful algal blooms in the river that affected the water quality throughout the region. So what I'm going to do is end there, and we'll pick up on Friday with the next installment of the water pollutants. Just remember, Wednesday is Veterans Day. It's a public holiday, and there is no class or school, so you'll get a full extra 2 days before you have to hear my voice again. So no class on Wednesday because of Veterans Day. I'll post a lecture online after this, and then your 10th worksheet just posted last night. There are only 2 more after this, so far they seem to be going pretty well. Everyone's doing fantastically. So almost there, 75% of the way there as it is. Hope everybody has a great week, and see you on Friday.